Okay, so we're going to compare two really simple compression algorithms for this particular string of text. So it's got 7 characters, AAB, AAAA, and we're going to compress it, and down here when we're done we'll see what the length of the compressed string is for comparison. And then we're going to do a different algorithm after that and compare the two. So let's look at algorithm 1. Starting at the first character, which is where this arrow is pointing at, we're going to write down a 1, look at the next character, and see if they match. If they match, we're going to add 1 to the number and move right. If not, we're going to write the character that we have pointed at here, and then we're going to write down that, we're going to write down a 1 and then move right. And we're going to keep doing that until we get to the end of the string here. So let's just see it in action here. Starting at the first character, write down a 1. Look at the character. Okay, so here, if it matches the next, which it does, we're going to add 1 to the number that we have written and move right. And then repeat step 2 until the end of the string is reached. So look at the character. If it matches the next, which it does not, we're going to write the character, and then we're going to write down a 1 and move right. Look at the character. If it matches the next, which it does not, we're going to write down the character, write a 1, and move right. Look at the character. If it matches the next, which it does, then we're going to add 1 to the number and move right. Do they match? Yes. So we add 1 to the number and move right. Do they match? Why, yes, they do. So we're going to add 1 to the number and move right. Okay, we've reached the end of this string here, so the last thing we're going to do is step 4, which is write the last character. Okay, so you can see with this one we've gotten not a very big compression ratio here. So it used to be 7 and now it's 6. And you can see what the sort of meaning of this string is. It's basically saying you have 2 A's followed by 1 B followed by 4 A's. So that's how I would read that. Now that doesn't seem like very much compression. So, we could take advantage of the fact that we have a lot of A's here in particular. In algorithm 2, we're actually looking for A's. We've decided, okay, this particular kind of string that we're going to compress typically has a lot of A's in it, and we want to capitalize on that fact. Now, it's going to turn out that this particular algorithm isn't so good if you don't have a lot of A's. Because what it's doing is compressing the number of A's and basically ignoring any other character. So, starting at the first character, we're going to write down a 0. We're going to look at the character, the one we're pointing at. If it's an A, we're going to add 1 to the number we have written down. If it's not, we're going to write whatever character we're looking at and then a 0 and move right. So we are going to keep doing this beginning at step 2 and moving through step 3 until we have passed the end of the string. Okay, so let's do it. We're going to write down a 0. We're going to look at our character, A. If it's an A, we're going to add 1 to the number. And then we're going to move right. Look at the character. If it's an A, then add 1 to the number and move right. If it's not an A, write the character, and then a 0, and move right. Okay, is it an A? Yes, so we're going to add 1 to the number and move right. Is it an A? Yes. So we're going to add 1 to the number and move right. Is it an A? Yes, it is. So add 1 and move right. Is it an A? Why, of course. So we're going to add 1 to the number and move right. Now we've gone past the end of the string, and that was our exit criterion for this particular little loop that we were running through here. So we're done. And what do we have? Well, we have a compressed string of length 3 versus 7. Now this one has a lot less characters in it, but again, it's very particular to strings with a lot of A's. So if there's a number, it's telling you the number of A's that there are. And if there isn't a number, if there's a character, that's just done verbatim. If you were to take this exact same string and sort of reverse it in the sense that it was B, B, A, B, 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 what would the compressed string look like? Well, since we're only using numbers to count the number of A's and everything else is done verbatim, it would look like this. And as you notice, that's not compressed at all. So this particular algorithm is really handy in a particular case and not in the other. Whereas algorithm 1 was more generalizable. And of course, that's part of the trade-off for getting a string that works over a bunch of general cases is that it doesn't compress as well.